Alright, so the app we chose to review is called Light Spectrometer Wavelength. You can use it to find the dominant wavelength of a light source as well as other information about the light waves. The main feature in the top half of the screen is a display which shows the dominant wavelength in the present light sources. The dominant wavelength is a concept that's commonly used in color science and perception theory. It refers to the wavelength of light that appears most prominently in a given color mixture or light source. In the app, there's a visual display going from blue to red being a large wavelength and blue being a small wavelength. It also has a given value in nanometers for the wavelength below it. A nanometer is equal to 1 billionth of a meter. And in the top right corner of the section of the screen, you can see the period of light displayed in femtoseconds. A femtosecond is equal to 10 to the negative 15th seconds. And then the top left is the frequency displayed in units of terahertz. 1 terahertz is equal to 10 to the 12th hertz. At the bottom of the section is the slider showing the color saturation of light sources, basically how strongly colored the light source is. In the lower section of the screen is a display showing the current view of the camera, including a smaller section where the actual measurements are taken. The size of the measurement area can be changed by dragging the adjacent arrows one way or another. The display shows various warning messages depending on the condition of the camera's view and how it may negatively affect the quality of the camera measurements. The app is used by pointing the camera at a white surface illuminated by the light source, not by aiming it at the light source directly. This means using a piece of paper, white wall, or desk, something like that, to reflect the light source into the camera. We can then use the display to take down whatever data we need. We can use the icons at the bottom of the screen to navigate to the second page, which allow us to better calibrate the app. By editing control points, we can remap certain input wavelengths to different output wavelengths. This allows us to account for any discrepancies caused by possible differences in camera sensors, and incorrect calibrations can lead to inaccuracies in measurements. Through our experiments, we didn't have a lot of tools available to accurately calibrate our own devices. This is done by using the edit button on the left of the mapping slide in order to change the mapping of a person's given point, which will then drag the curve along with it, smoothly remapping all other possible input and output values. The last section of the app is the settings menu, which can be used to change various settings as well as an access page. There's also an information page in the top right.
So for our experiment, we measured the wavelength of sunlight on a white surface from different distances. We tried distances of 13, 26, 52, and 104 inches from the surface, noting down the light wavelength at each distance. The reading from the app remained at a relatively consistent 569 nanometers despite the changing distance, showing that the two variables are likely not linked in any meaningful way. As we got further from the wall, the confidence of the app was reduced, as well as the saturation readings, which seemed so there was some correlation between saturation and distance, but maybe not a super huge or meaningful one. Our readings seem to be consistent with accepted values for sunlight peak wavelength, especially during sunset times, since they were on the lower end of that potential spectrum, showing that the app works well and better than we expected it to be completely honest. Our experiment, while not giving interesting or necessarily useful results, did help show the accuracy and consistency of the app, as well as its ability to work despite being used in a context not initially intended, more because it was more than a few feet from the surface, which probably really isn't really the way it's meant to be used. All in all, this app seems quite effective, precise, and accurate, though maybe not the most useful. I can't really think of a context in which I'd use this app, and it only has one very niche use, really. I think for what it does, it works extremely well. It works great out of the box and doesn't add anything more than what's needed, while still including everything that I feel like it should have. The UI is really, really nice. Everything's sort of visually available. I can sort of see what's going on really easily, and it's nice that it includes conversions from wavelength to frequency and things like that, so that we don't have to do too much math to get those if we were wanting to use them. So I think that's really nice. If it really wasn't such a seemingly useless app or very niche use case app, I'd probably rate it higher. But as it stands, I think I'd probably give it a 5 or 6 out of 10.
To start, I would say that I think this is a really cool app. It has a lot of really well designed features, starting with usability. It's super self explanatory. It has an information page in the top right, I believe, which is really easy to see, really easy to get to. And it has a lot of good information there. It tells you exactly how to use the app, what everything on the app does, and it even has a lot of information about light waves themselves. I think I learned some from the information page. Um, the app itself also seems really reliable. It's obviously kind of hard to tell with the limited resources we have, but it seemed accurate based on what we did have. And I did, however, notice that the app seemed to the camera turned off whenever I switched tabs or went to my settings page, which was kind of annoying. Not the biggest deal, but I had to relaunch the app whenever I did that. Which for me, in my case, was just starting screen recordings. It would always turn the camera off. Other than that, the app itself is free, but it only gives you a few weeks, I believe, at free use. After that, it's an additional $1 per month or $7 lifetime access fee to continue usage. Obviously, a better deal than $1 a month for people who are going to continue using it. Also, I think the calibration tools are really cool and unique. It's kind of fun to play around with even. So pros, I would say, are that it's easy to use, it's accurate, fun to toy around with, obviously. The cons, I would say, are that it's not free for long-term use. It only analyzes dominant wavelengths of light, and the camera shuts down often whenever you turn off the camera. But other than that, it seems great. I think I would rate it a 5 out of 10 stars, though, because the cons seem a little bit stronger than the pros.